x1 plus x2, x2 plus x3.
Okay, now we'll be discussing
And this is x3 plus
systems
x4.
of
The first step is you identify
linear equations.
coefficients of each variable.
The concept is
Each column corresponds to one variable.
what is a linear system. Okay,
Okay. So this would
it is
be
a collection of linear equations in the same variables.
0, 1, 1, 0, 0, 1.
It a linear system
Now several other concepts is
is a collection of linear equations in the same variable. Okay, now if we take an example, 2x1 minus 3x2 plus x equals 6 and x1 plus 4x2 plus 2x3 equals 5. So now this a system of equations can be written as augmented matrix coefficient matrix and RHS vector. Okay, the example can be like in this case it is 2 minus 3 1 this is 6 1 4 2 and this is 5. Okay, now the row operations, let us talk about the row operations. Okay, the allowed operations are swap two rows, multiply by non-zero scalar add a multiple of one row to another.
Now you have
Okay.
uh,
The next thing is there is another for that is called as row echelon for.
some concepts that the transformations determined by determined by images of basis vectors. Okay. Not every transformation is linear. Not every
So the first thing is REF,
has a matrix.
row echelon form.
Okay.
Every
Every transformation
Okay. So the row
every
echelon form.
transformation must send 0
We
to
talk
0.
about the row echelon REF.
If
Uh,
T goes through, I mean,
all
another
rows,
example,
all
the
0
3 by 2
rows.
matrix cannot be 1 to 1.
All 0 rows
Then you have
are at the bottom. Leading entry. The
if you
leading
have
entry
to draw or sketch an image of a vector,
or the first non-zero of each row is to the right of the row above. Okay. All entries below a leading entry are 0. Below a leading entry
the first step is
are 0. Then you have a reduced REF.
express the vector as a combination of basis vectors.
Okay. It is definitely an REF. Every leading entry should be
Okay.
every
Apply transformations apply transformations
leading entry is 1.
linearly.
Each
Okay. Then draw
1 is the only
result using
non-zero
2 can be like
in
transformation
its
of
column.
2 comma 1 will be 2 transformation of okay.
Then you have a Gaussian elimination.
So if transformation matrix is
Okay. Here you are using
okay, the transformation of x comma y would be
row operations to reduce the augmented matrix.
5y x plus 2y. Okay.
To REF or RREF
It's about
to solve. Okay. Then you have the solution types. It is
if this is like this, you need
a
to find
unique
the
solution.
transformation vector. Okay. x1, x2 and x3 that is equal to
One set of values
3x1 minus 2x2 minus 4x1
satisfies all
plus x1
equations.
minus x2 plus x3. Okay.
Okay.
A would be like ABC D, E, F, G, H, I. Okay. So A, x1, x2, x3 is equal to A x1 plus B x2 plus C x3, B x1 plus P x2 plus F x3, and G x1 plus H x2 plus I x3. So this will be like 3. This if you match with this, it will be 3
Okay. No solution would be one set of values. Sorry, it is an inconsistent system.
3 0 minus 2
So
minus 4
and then you have infinitely many solutions.
0
Free variables.
1 minus 1 and okay. So this is how you do it. Okay. This is how you find out the transformation matrix. Okay. This is how you find out the transformation matrix.
Okay. When there are free variables, write the solution in a parametric isometric vector form. Like x is equals to p plus dv. Okay. Uh, then you have system. The form is transformation matrix multiplied by x is equal to 0. Non-trivial solutions exist if there are free variables. So non-trivial solutions will exist if there are free variables. Then you have matrix inverses. Okay, if Ax equals B, x will be A inverse of B. Okay. Okay. Mm, the next would be forming an augmented matrix. Say for example, uh, sorry. So forming of an augmented matrix, if it is like x plus 2y equals 3 and 3x minus y equals 4, the augmented matrix would be 1, 2, 3 minus 1, 3, 4. Okay. The same thing, if you want to convert it into RREF, if this is converted into RREF, okay, you can do R2, you do row operations. Okay, so this would be 1, 2, 0, minus 7, 3, minus 5. Okay, then you do R2 divided by 7, make one pivot element. R2 divided by 7, what you get is 1, 2, 0, 1, 3, 5 by 7, and then what you do is from this you eliminate this 2, okay, by R1 gives R1 minus 2R2. So this is 1, 0, 0, 1, 11 by 7, 5 by 7. Okay, so the x will be equal to 11 by 7, y will be equal to 5 by 7. Okay, now if there are infinite solutions, okay, the augmented matrix is 1 1 1 2 2 2. This is 2 4. Okay, now you do R2, new R2 is R2 minus 2R1. Okay, so it becomes 1 1 1 2 0 0 0 0. Okay, the free variables, let us say y and z are free variables. Okay, x will be equal to 2 minus s minus, if y we set it equal to s and z we set it equal to t. Okay, so in vector form this becomes xyz is equal to 2 0 0 minus 1 plus minus 1 0 1. Then you have a homogeneous system. In a homogeneous system, like this is x plus y plus z equals 0, x minus 2y plus z equals 0. So this is 1 1 1 1 minus 2 1 0 0. Okay, so R2 will be equal to R2 minus R1. This is 1 1 1 0 minus 3 0. This is 0. This is 0. R2 divided by negative 3, you get 1 0 1 0. Now you put uh, R1 is R1 minus R2, 1 0 1 0 1 0 0 0. Okay, if we set free variable z equals t, x will be equal to minus t, y will be equal to 0, z equals t. So t in the vector form it is t minus 1 0 1. Then you have 2x plus 3y equals 5. This is x minus y equals 1. Now you are using inverse to solve it. Okay, a will be equal to 2 3 1 minus 1, b will be equal to 5 1. Okay, a inverse, it will be 1 by minus 2 minus 3 minus 1 minus 1 minus 3 into 2, that will be 1 by minus 5 minus 1 minus 1 minus 3 2 equal to 1 by 1 over 5 3 over 5 1 over 5 minus 2 over 5. So x will be equal to A inverse of B, that is equal to 1 over 5 3 over 5 1 over 5 2 over 5 multiplied by 5 1. If you solve this, you will get 1 over 5 into 5 plus 3 over 5 into 1. So 1 plus 1 so that would be equal to 2 0. Okay, now systems can be by row reduction. The solution set depends on pivots and free variables. RREF gives solution straight away. Homogeneous systems will have at least one solution. Only when inverses solve Ax equal to y, only when it is invertible. Invertible means the determinant of A should not be equal to 0. Okay.
Then standard basis variables. Standard matrix. Coefficient matrix. Okay, the allowed operations are okay. All entries below a leading entry are below a leading entry. The first step is are 0. Then you have a reduced RF express Okay, K would be
सर मैं एक एक्सपो में पार्टिसिपेट कर रही थी
Okay. No solution would be one set of values. Sorry, it is an inconsistent system. So, and then we have infinitely many solutions. Free variables.
This is how you find out the transformation matrix. Okay, this is how you find out the transformation matrix.
Okay. When there are free variables, when there are free variables,